Okay, there are two phrases, or two definitions that you're going to need to know when you're dealing with infinite geometric series. And that's a very important phrase right there, infinite geometric series, infinite geometric series. Whether or not it converges or diverges, and I think it's kind of important that you get a visual of what that really means. It converges if it approaches a single value. It diverges if it approaches infinity. It's going to go on and on forever. So let me give you a couple examples. A convergent series, let's suppose, we did this one in class, let's suppose you have a piece of paper and you tear it in half and lay that down. And then you tear what you have left in your hand in half, which would be half of a half. And then you tear that in half, and then you tear that in half. And we can keep going with this, but we're going to do this forever and ever and ever. And so it's infinite. It's geometric because each of these is half of the one before it, and it's a series because we're adding them. So again, infinite because it goes on. Geometric because there's a common ratio. Each of these is half of the one before it, and it's a series because we're adding. Now, as we do this, we're going to end up using this formula right here. It's the sum of an infinite geometric series. Sum of an infinite geometric sequence, which is a sequence and series are used interchangeably here. But it's going to be the first term over 1 minus the common ratio. So 1/2 over 1 minus 1/2, and when you do all that math, you end up with 1. So basically, you would be laying down one sheet of paper. However, if you have a divergent series, it's going to approach infinity. So let's do a different one. Let's let R be something different, like 4. So we're just going to make up a series here. So 1 plus, we're going to multiply by 4, and then we're going to multiply by 4, and then we're going to multiply by 4, and then we're going to multiply by 4. You can see where this is going. Obviously, the numbers are getting bigger, and so when we add this, we're going to get a huge, huge, huge answer. And this one is not going to work. So we end up with basically infinity. And it's in a situation like this where the formula does not work. If you notice on the formulas, it says that this formula that we used here would work if R is less than 1. And so if R is less than 1, it converges. If your common ratio is less than 1, it's going to converge. So R is less than 1. There's a slight little catch to that. Actually, the absolute value of R is less than 1. And it's going to diverge otherwise, unless R is equal to 1.